So yeah, programming and stuff. Yeah, just a second. Yeah, I really need to do a script so that when I switch to my private window, I don't. Someone's here. Someone's here. See all the types. Oh yeah. Speaking of that, you know, I did not credit them. I should. So let's go to for. Wait, does it forage? It's in objects. And it's fine. That's threads and stuff. So functions. What the hell? That works. What the hell? Oh, it's just a thread. We just need to increase this. Okay, it's working. Should work. Yeah, there we go. Okay. We should have a separate. Oh, whoops. E asset. We're gonna put that here. Session error. Just a second, I'm just gonna check something. Let's see. Where's the oh yeah. Speaking of programming, one view is A. We have those. closure name fn greet name control N. We're just gonna copy paste this of that, indent that, return greet. I mean, oh, oops, greet. So here we're gonna go var greet Alexi. Oh, oops, greet Alexi closure Alexi, and then greet Alexi. No, we don't need to pause anything. Sure. Yep. So every time we call Alexi. Yep. Okay. Well, there's a memory leak. Let's see what it is. So in Mylan's third group, eval statement, call function 4115. Yeah. In 4839. Okay, that's weird. Oh wait, I don't have GDB. GDB Myla. Oh, GDB, not P. Run examples all Myla. And we just let it hit the breakpoint there. There we go. So we're gonna call function. So we're gonna, how do I just define val? Wait. How to print a struct in GDB. P. Okay. Fn val. Oh, there it is. Cool. So let's see what we're gonna be. So that's null. Oh, it's a tagged error. Syntax error. What? Nande? The opaque is triggered here. Oh no, that's just, yeah, that's just the interpretations of the, because this is a union. So yeah, it's actually, it's not this, it's this. That's what we care about. So print fn val v dot fn. There it is. So yeah, oh, we just called breakpoint. It's called breakpoint. Yeah, there's the source. Yeah, breakpoint name closure. Yeah, got you. Native breakpoint. So we just step equal primary step minus free args step. I'll just press enter. Right? There we go. There. And we're in main. Okay, so yep, we just, oh okay, so there is no, so it's not deterministic, but we get some memory leaks on program exit. It's not always, I believe. It didn't, oh no, never mind. It's worse now. What's the problem though? Ayla malloc Sturgeon eval state Sturgeon in ML string. Eval statement 5855. Oh, we don't free it? What? FN name. We don't free FN name. I believe we do. What the hell? Um. So function there it is, and yes, we do free the name if it's not null. We don't need to explicitly check that. So if it's not null, we free it. Something's off with it. So val kill, we should have, yeah, we also should free. Yep, there it is. We don't return prematurely. We also clear the closures. So what the hell? It only started when I did this. But this should be, yeah, no, this, yeah. No, that should not be how. Yeah, no, it's not that. It's probably one of these. So let's try commenting this. It's probably, yeah, it's consistent now. GDB doesn't let me, oh, whoops, doesn't, yeah, look, it's the closure. Was? That should be, oh, whoops. Your breakpoint, why don't we have dump parser? There we go. Where was I? RV, that. Gritylexie. It's one. It's one. But it's what? When you call Gritylexie, it shouldn't. It's a closure. It's in the local scope of that damn thing. Error. Yeah. It all has one. Yeah, it all has reference 1. But we get that. Yeah, we're gonna call it at the very bottom. Just decrease this up to 2 seconds. Boom. So let's see what would have leaked. It's all 1. Yeah, it's all 1. All of the reference count are 1. So there shouldn't be any errors. That's weird. 6 bytes leak in 1 location. Why? Why would it be leaked? Right click of 6 bytes. 6. It's not 6. It's not 6. 6 bytes. So the name is 6. Bytes leaked in 5855, which is this, which is under the function statement. Oh, what? Oh, I did not make it again. I forgot I had that issue. Now it should be, yep, nothing. It's an issue. It doesn't free it when it should. It's weird. I hate it. I don't know why it doesn't let me free. And if I go raw here, the ref count hits 0, and then we're gonna be accessing memory. So it's the closure that this is happening to. Because look, um, I fixed it. I fixed it. No, look, still a lambda, still treated as a lambda. Oh, that's no, that's correct. Excuse me. It didn't get printed anywhere. Oh, I forgot to. Oh my goodness, I can't type. Okay, there it is. So now it did work, but yeah, we cannot set it raw. But if we don't set it raw, it's gonna leak memory. Oh, I see now. Du bist ein so scheiße. Was ist Ihr Problem? Was ist Ihr Problem? Was ist Ihr Problem? Was ist dein Problem? 6 bytes. There's no other. That is not 6 bytes. No, not at all. So where could it be? No, we don't. It's in var. This is what's causing. We don't check if there's a pre-existing name. We need to do that first set. It's gonna work now. Hell yeah. No more memory leaks. Good. What? Oh yeah, I forgot. This is in German. My browser is German. Mit Google suchen oder Adresse eingeben. Seiten importieren. What? Importieren. Die Seiten aus einem anderen Browser so Firefox importieren. I forgot that I can somewhat speak German. Hallo? Hallo? Ich sprechen Deutsch. Deutsch. Was ist Deutsch? Ja, Deutsch. Ich spreche Deutsch. Die oder die Sprache Deutsch. Yo! Hello! Rizim Hanse. I am here programming and updating my language, and I just fixed the problem. We can now set the names. Back then it didn't. So yeah. And speaking of that, in FN, in eval, nope, the other one, this one, function literal, what? Is this the, yeah, is this, it's eval primary, so now here, in name, the function name, we're gonna explicitly set it to v dot fn name, set it to lambda, so Myla stir dupe. How's it, oh my goodness, how have you been? Lambda. So we should get lambdas if there are any. Yeah, we have threading in Myla now. Threads. Cooperative threads though, because I wanted it to support Android, because I do program on Android occasionally when I don't have access to my laptop. So, yeah, it's cooperative threading, but it works. The only problem is you need to manually check if your thread is asking to be killed. So we can basically have a thread here, and we have to, like, because pthread test cancel and pthread cancel doesn't exist in Android because Google is a piece of shit. So yeah, we have cooperative threading in Myla. So for example, I have a while loop here that goes on forever, and since this isn't this is not a daemon thread by default, you need to be dangerous with these kinds of threads, or they will become immortal. They will become immortal. So we have to go here and thread the check cancel. Oh, is it check cancel? Or just not text? Oh yeah, it's check cancel. Check cancel and cancel. So we have that, and we need to pass the ID to it. So now what we're gonna do is we're just gonna cancel it. So we're gonna time that sleep underscore sleep in 10 seconds. Actually 1 second, and then we're gonna go, whoops, I hate multiple cursors. We're gonna go thread dot cancel. Don't kill logic runs. It runs. It always runs. We can see ended because, and then underscore reason. So underscore reason is it's just gonna be a string set. Yeah, it's just, yeah, and it will be, well, you'll see. So yeah, that. Oh, I should have just, yeah. And yeah, ended because cancelled. As you can see, we can determine how it got terminated. So if we set this to be a daemon thread, set daemon thread It's gonna die when the interpreter exits. It's gonna say interpreter halt. Yep, there it is. And there's, oh, my enemy. My enemy. No. What is the problem? I believe we do call minus threads cleanup. Oh, we call it twice in Myla the init. Oh no, we don't. Well, then we now do thread cleanup. Let's see. It is still the problem. Why? Why? No, we join it. Oh, it's a, wait, no, it's a daemon thread. So we do. Oh, because the thread. Oh, but it halts. No, I'm not halts. It freezes. What the hell? We don't. Yeah, if it has context and status is less than 2, and if it's not a daemon thread, we wait on it. Then we just do that. Otherwise, we do this. That's annoying. So in the end, we would need to. Nah, who cares? Yeah, no. I don't know why that's happening. I think I fixed it once, or maybe because yeah. Let's try that. So where is it? Threading. Who is the? Oh, yeah, here. We just bind it. So vars dot bind thread. Make sure that we have our own local copy in the local scope of the thread, and it should not. It still does that. The problem is, before the thread finishes, the interpreter cleans it up. So when the thread finally exits, well, I guess that's edge case. But yeah, we can just go thread dot join here, thread, and we should actually see that normal. It ended normally. Actually, no, cancelled. Wait, no. Oh, that just hangs because we didn't cancel it. Let's implement a counter then. Yeah, let's just not a counter, more like just a timer of 2 seconds. So that should. Now we're waiting for this thread to finish, and there it is, and that becomes normal. So those are the 3 cases that reason may be set: normal, interpreter halt, and cancelled. So, and on kill makes sure that it always runs. So yeah, hooray! I mean, it always runs the cleanup code. So we also have this. Yeah. See this? It's cursed. It's cursed. So these are ID strings, and as you can see by the comment, using ID strings you can use anything as a name. Yeah. Actually, I think Lua supports this. Lua supports this because UTF-8 stuff. They also support it in strings, I believe. So if I do that there, and yeah, it does. Okay. So yeah, this is a variable. That's a variable, and you can use not just emojis. You can use spaces. It still prints 90 up there. Or yeah, it's cursed. Or just empty ID strings. It's valid. It's it's valid. It's cursed because it's cursed. The reason why I added this is because I can write in any language. You can technically write in any language now. so I can write in German, in Chinese without needing extra stuff. And that would be very helpful because, well, programming has been dominated by the English language, as you can already see. And I'm actually planning, yeah, on further problematic stuff because I'm planning to provide aliasing. So, like in C, right, you can define macros because you're literally just text replacement, text substitution, if you will. So I can just go define here and go dot here and say that's main. And now, oh, actually, no, you can't go. Internal pointer. Internal pointer variable. And now you can use it everywhere as substitute for var. So basically, yeah, it's cursed. So I'm not adding that anyway. I'm not adding that anymore because I just realized how idiotic that would be to handle code bases with multiple languages. But yeah, now you can name your variables anything. So that I just stuck with that. So anything you can put an identifier, you can use ID strings because it's treated the same way. In parse ident, the logic for parsing identifiers, as you can see, there's a parse ident string, so that's the ID strings. Then here's the parse ident, the normal parse ident. So you can see we check if it starts with that single quotes there, and if it does, it delegates it to parse ident string, and then it handles the rest. So yeah, I can name my functions everything, anything. So you can name an object, I don't know, rocket. Oh, speaking of rocket, the flyby of Artemis last night was heavenly. And then here we can go function. Oh, whoops, FN. And let's say, it explode. It explode. No. Boom. There we go. And let's name it it's a starship. Adrenaline. Self name exploded. And now we can do this. Oh, whoops. We can do this. That's valid code. that's valid code. It's gonna run. It's gonna run, and then it's, yep, there it is. Oh, I need to print the function. Let me just check that. Probably some print validity. Oh, yes. Whoops. So AI couldn't have thought of this. AI cannot do this. Yes, quality code. So anyways, I can English to German. I don't have a keyboard, but I can write German. What's this? What the hell? It's better than no. Japanese is much more better. Not rocket. Rakete. Actually, that makes sense. So you can. Oh wait, no. That there's nothing in there. Starship. Romship. Why is there no umlauts? That's the reason why I'm. Let's go to Japanese then. It's just gonna be Rocketo. There it is. And then explode. Bakahatsu suru. And we can put it there. And Myla won't do anything about it. It would run. So now Japanese people can understand my code. Well, there it is. Demonstrating UTF-8 support as identifiers. Oh my goodness. Speaking of, yeah, we have that. Oh yeah, it's my first time streaming with Farina in the background. Anyways. Oh, by the way, how do you like what? We don't support slicing yet because it only supports indexing. If I there's no syntax yet, but we do have ranges, and I might actually support um having this with syntax, so like I can just go 90 dot dot 90 and then 100. No, that's just equal to range 90 to 100 exclusive, so it's gonna go to 99 max. So yeah, or we could also, yeah, just like bash actually, so we can step two at a time and stuff. Yeah, like that. Yeah, or I might support it as colons. As you can see, I really like colons. Colons there. And earlier when I called the methods, actually that syntax was inspired by Lua. And because I just don't have, I already, here, I'm just gonna explain to you. So this, so let me just go call it ns, is v is valid code. Dots don't have any special meaning, they're just namespaces. So if I go println ns, that's gonna be null because that doesn't exist. Let me just move this around here. Oh yeah, and oh no, it's in built-ins. Native breakpoint. So yeah, as you can see, there it is. So yep, there it is. So it supports, well, almost every architecture that I could think of. Even I forgot what this is. And yeah, this is wait, what? Oh yeah, I forgot. i386 had a debug trap. Not a debug trap. Debugger trap. That's cool. So, anyways, yeah. Speaking of updates, we have the breakpoint function now, so that's easier to debug the interpreter when it does a hiccup. And yeah, we also have time milliseconds. Time, yeah, sleep milliseconds. I haven't updated that since anything. Actually, it can. Actually, the implementation sleeps in nanoseconds. So I just had. Oh, can you see it here? Time. I can just. There we go. So you can see we just multiply it by 1,000 because this is was it microseconds? Not milliseconds. It's microseconds, and I hate it. Why? Why would micros? So I'm just gonna change that just for a little bit more readability because, yeah, with the sleep micros. So yeah. Anyways, now if you run this, yep, it's null. But if we just whoops. Oh yeah. We support. That's multi-lines, by the way. So we can go ns.v and it brings that. So if you're wondering what this syntax is, the exclamation point and then the curly brackets, it's just a string. It's a type of string. It's basically like TCL. Those called the curly braces are just strings. Well, this we just did that. So we could just go here, ln, write normal code, but it would be interpreted as a string. And you don't need to escape curly brackets as long as they're I need to support that, but as long as the brackets inside are balanced. If they're in a string, it's alright. It won't affect anything. Hopefully, this works. Yeah, as you can see, there it is. So you can do that basically. So now we can just go here and write some code, and we can evaluate it using the eval statement, a function call. So you just go eval ns.v, and then it's gonna print hello world. So you can see there. So yeah, that's that. And now object, there's no support for attribute access yet. You need to use the dictionary syntax because it is a dictionary. It's just a dictionary. So like var name, my name, and if I go here and print ln. Oh, and speaking of dictionaries, we have literals now for them. So you'll see that's the literal for a dictionary now. So if I copy paste this and put it in here, that would be the same as that. As you can see, same input. So lists, however, just remove that sign and start typing. So 90, 70, 60, and then 90, and boom, there it is. And you can have an empty list and an empty dictionary. There you go. So yeah, it works. I'm proud of that. So there's also new numerical types. So you have the big integers and the big floats. Actually, it's here. If you can see, it's demonstrated down here in the types. Here it is. So as you can see, yeah, here you'll find out. A big int or a bint is a 128-bit integer. We already use a C-long for integers, so it's by default 64 bits in most platforms, especially in Unix platforms. I mean Unix or POSIX platforms. Forgive me for that. And B integers. Oh, why is it? Oh yeah, I forgot. So B integers are 128 bits long. And there's no unsigned variant because it's big. It has 127 raised to 2 raised to 127 minus 1 bit because signed bit, minus 1 because yeah, that's how it is. It is 170 billion. That's the max value you can have. There's the scientific notation, and that's the result. So yeah, that's big. It's big. And for floats, it's way bigger. Normal doubles can already surpass 128-bit integers. I know, right? And not just 38 zeros. Those zeros, yeah, it's big. And big floats can reach way higher than that. 128-bit float, signed float, max value. More. Look at that. Holy crap. Holy. It's glitching out the... That's 128-bit float. And a 64-bit float is enough to surpass 128-bit integers. Look at this shifted to... It's more than a Google. You can simulate the solar system in centimeters and still have a ton left. You could probably simulate way past the Oort cloud with this. Signed, by the way, signed. Oh my goodness. So yeah, Mina can officially simulate the solar system out of the box. How am I? Yeah, and because this is native, it's not slow when it's calculating stuff. because in Python, arbitrarily sized integers are slow, because it's slow bookkeeping and stuff. But this is like in the methods of like what, three assembly instructions. You know what? Let's test that. Test 3.c. I mean 2.c. So we're gonna go. We're not gonna do anything. Just gonna go int main, and we're just gonna go here, turn 0, and just have here int 128. Oh, by the way, this is only available for GCC and Clang because it's a compiler extension, because people didn't think 128 bits was needed. Well, now I do. So we just go 0, x plus equal 1. So we should be able to go here and see the output for it. 2.c dash o test 2.s. So you should be able to see that now. So let's see. Look at that. It's just a few assembly instructions. So there's no. Let me just is there a gas support? Just a second. There's no. Oh, there it is. So go to view. I mean view. What the hell? Syntax. There we go. So yeah, there's a few. These are just. We can remove those. Those are just. Oh wait, actually we can't remove the global one. And yeah. So it's just metadata in there. This is also metadata. So yeah. So here, let's see, 128 bits. That's how many bytes is that? 128 divided by 8. 16. Okay, so that's what that's what I was seeing here. Yeah, this. So it's allocating on the stack a 128 bit integer, and then it's this is the integer that it's just the wait, why did it just weird? It's weird. Let me just this might help us understand it a little bit better. Reload. It's even more shorter. We added 1, and because we didn't. Wait, did I accidentally put 3 there? It just removed it because we don't use it anywhere. Yeah, as you can see, it just returns there. GCC is cool. Decades of compiler optimizations. So this is the so this is the lowest. So yeah, we allocate that there. And what is this? Move 0. What's this? Is this the integer that we're subtracting? Oh yeah, it is. And then this is when we add. Oh wait, what? Add CQ. Compare something, or is this? I don't know. Oh, probably because we have. Oh, it's adding multiple. Oh, okay. It's treating it as 2 bytes. I mean, what? Wait, let me just handle that. It's treating it as 4 bytes each. There's what? So yeah, 8 bytes. So this is actually too long. So it's probably implemented as a high, the high part, and then the low part. That's why we're seeing it. So add CQ probably handles overflow. So if the low part overflows, it makes sure that those overflowed parts go to high. So it acts like a single value, even though it's treated even here as two 64-bit integers. Yeah. Oh yeah, definitely. So let's see this. Gas, Intel. Yeah. Yeah, add with carry. There it is. Add with carry. Oh yeah, here. Add CQ. 64-bit. In Intel GAS, Intel syntax, the Q suffix, code word. So, wow. How did I understand this? Yeah. So, this is probably just realigning the stack or something. Wait, no, this is, no, this is just metadata as well. Probably, I don't know. So, yeah. This is cool. Oh, wait, no, it's the line? Oh. I see. But yeah, it's pretty cool actually. So, oh yeah, I forgot I changed the thing. So let me just that. So we should see the numbers change. No, it did not change. So what's CFA register though? What it? Oh no! I just realized. No. No. Why are you using tabs? No. It's using... No! Why are you using tabs? No! That ruined my view of GCC. What? Why are you using tabs? No! You know what? To make it more... So, yeah. Let me just indentation. So, yeah, there we go. You know... That's how it's displayed by default. So, it's yeah. What? Why did it become tabs? No! Why is it No! Why is it tabs? No! What? Why is that a tab? No! Hell no. I am cancel. Tab. Hell yeah. I am translating that. No. Yeah, there. True. How long? What? What the hell? Salay na such. What? What's wrong with this? Yeah, tabs are a nemesis of mine. I hate tabs. They're just ugly. Mixture. I don't know. It's just. I don't know. Yes, you're saving 3 bytes of information, but I don't care. What's it saying? Yeah, parse shading character. No, it's not that. What shading characters? What do you mean? Oh, there it is. Found it. There you go. So, yeah. Use tab stops. What's this? If translate tabs to species is true, use tab stops will make tabs and backspace delete insert delete all. Insert and delete up to the next tab stop. Oh, that's actually cool. Oh yeah, it's already on. Detect auto detect indentation. Calculate auto indent. Okay. Smart ident. Okay, that's cool. So let me just. Oh, whoops. So see. No. Indentation. Indent using spaces. View. Indentation. Convert indentation to spaces. Ah, that's much for better. Indentation. Oh, that's way too much. There we go. So yay, we fixed the tabs. Good. So the fact that I can recognize C code is pretty cool. I mean assembly code. Oh, whoops. So let's say we're gonna calculate, I don't know, x is equal to 2. I use, what was that? I use Sway. So it's a Wayland compositor. It's built on top of Wayland. Yeah, so I'm just, never mind. Yeah, no, I'm using, just trust me on that. So anyways, let's go. Oh, no, I forgot I have to use this. X. And just cause so So let's see. So we oh yeah, because we're at the lowest optimization. I doubt that GCC isn't happy. Yeah, just one. Just one level and it's already gone. To avoid that, we're gonna go printf on it. Oh yeah, I forgot. Holy, we can't really print this. There's no there's no format specifier for this. Well, I guess we can't do anything about it. What if we try to return it? Will it? There's no warnings. So let's see. Oh, wrong one. So here, it does not. It does nothing. A global. Oh, whoops. I'm gonna make that a global. What the hell? And we're gonna make it volatile so it doesn't mess up. There it is. It doesn't optimize it away. It's weird. It's still there. Oh, speaking of volatile, I forgot that when stuff is volatile, there it is. So when you're linking, you can access it from other scripts. So if we put, it's still there. Oh, right. So when you label a variable volatile, it means that this value, not only would it change randomly and we don't know how it would change, but it also means that there might be someone who is watching this value change. So that's why every instruction here isn't optimized away, because it's volatile. We can't make sure that optimizing this is safe. So yeah, GCC is forced to do this. That's cool. That's cool. That is very cool. I'm just gonna blow my nose for a second. It's very annoying. It's just a second. So I'm back. Yeah, that's pretty cool. So if we instead turn that into an extern, it's gonna Yep, there it is. There it is. So what the hell does this mean? Oh, it just clears. What? What if he? That's weird. Okay, so there it is. Oh, what? No, I don't see any hex here. What? Huh? Oh, this is okay, so what? What if we set it to 0 here? It's giving us warning because it's an extern. Yeah. Even a warning down there. Oh, now it's there. Okay. And now, yep, there it is. So if we put volatile here, it's gonna be forced to do, like, yeah. So let's see how it sets. Holy, that's a ton. That is a ton. What the hell? So let me just remove this and see how it sets the. So let's see. So this is our 0. So it's 16 bytes. just 0, and then it just move Q. Okay, so we just move 8 to it because we initialize it with, oh yeah, here 8, and then we just move 0 to the upper part. Hello, welcome to the stream. I'm just seeing how GCC handles this 128-bit integer. So yeah, and then we, what? Whoa. What? Move it to RDX. I don't understand this now. So for now, so we set it to 8, yeah, because it's it's uninitialized yet. Yet it's not initialized yet. Oh my goodness, I cannot talk. So you move 0 to the upper, so the high part of the 128-bit integer, and you move it to, oh, this is a 128-bit register. Wait, no, wait, what? What is this wait, stack stuff? It's stuck. It's the stack. I think. I don't know. What the hell? What is our IP anyway? Gas Intel RIP. Enables position independent code by referencing data. Oh! So it is, oh yeah, instruction pointer. That's what, oh, I was close to guessing it. Okay. So it's just this. What? So you're telling me, what, huh? Eh? What? Oh, okay, so it's, I see. I see. It's fine. You'll soon understand how this works. So yeah, we have that. And then after we set this to 8, we add 8 to it again? What? Why did it happen twice? Yeah, it happened twice. It moved it. Oh. What? Why are we moving RAX into X? RDX to there. To there. What? So, wait, no, what? How, what, huh? How is gas written? Is it destination in operands or the backwards? Intel and NASM has, it's weird. Gas Intel move semantics. MOV semantics. No. Move. Just move. But yeah, so destination and source. So this is, what? Move Q. So source destination. Oh! Okay, so it's, okay, so, yeah, it's that. So, my motion stands. Why is it being put into RAX and RDX then? Oh, we're returning X. Oh my goodness, how I'm blind. We're returning... I forgot that we're returning X right there. So, that's what this is doing. I see. Wow, that's... So, we're just doing that. So, what if we... What if we do restrict though? Okay, now that's... No, it doesn't work because it needs to be a pointer. So, well then... Oop. Do that, and dereference it, and set it. So let's see how it does. Okay, it doesn't. So yeah, cannot do that. Anyways, You know what? I'm bored. Let's program in assembly. Let's program in assembly. So let me just edit the stream title. So yeah. Huh? Programming in gas Intel safe. So yeah, no, put that analytics and then just boop. So yeah. Hylomorphism. What the hell is that? Genetic increasing model is what language is that from? Yeah, yeah. What language is that from? I'm intrigued. Let me just prepare. Now we're gonna click here. Myla. No. We're gonna learn the CF5 basically. Make your CF5. And then touch CFFI.s. I know, right? What's hylomorphism? Hylo language. I think I've seen that somewhere. Oh, whoops. How did that not copy? Hylomorphism. Hylo language. Hylo. A systems programming language all in on value semantics and generic programming. What? So it's assigning to radians, I suppose? In-out? What's in-out mean? Okay, so... Oh, it's a GV... Oh, wait, what? Okay. Yes, I am asking, who owns the contents of a doubly linked list? So let's see. So documentation. Let's see. I'm intrigued. Let's see the hello world. It's not bad. So why can it just not be inferred that main is public? That's just asking for Java stuff. What does that column mean? Copy that function into okay. Modules. Oh, that's cool. They have modules. So you can bundle multiple files in a single module by passing all of them as argument stage C. For example, in a separate file, we can define a function that prints specialist greeting and call it from Hylo. Oh no, that's just make file shenanigans. No. Oh, okay, that's cool. So I can just specify the dictionary of all of the files that I need to be included. But the problem is, okay, finally. I thought that didn't exist. Okay, good. Almost got C. What does it C? What C was that? Old C. Old C. Wait, when did C have directives? Because there's like a version of C. 1973. So before 1973, there was no preprocessor. So what you needed to do, there's embed. I just anyways, there's no C processor. So just like here in Hylo, you need to do it like like that. So you have your main.c file and then your dependencies in the same single command. So anyways, that's cool. Bindings. Let's see. Let can be initialized with a yep. It is not possible to modify the bound object during. Okay. What? Oh, okay, I guess. Note, however, that such a projection is not a reference in the usual sense. It has full ownership over the value it projects, which cannot be accessed except through that projection. The lifetime of a binding denotes the region of the program where the value of that binding is accessed. The lifetime always ends after the last expression in which the binding occurs, for which example, the lifetime of wait ends after the first call to print in the program below. Okay. Some operations are said to be consuming because they force end the lifetime of a binding. In other words, they must be the last use of the consume binding. For example, assigning to into a var binding consumes the source of the assignment. Similarly, superimposition comes. Oh, what? Why would it? So it has implicit borrow semantics. It's just rust hiding in the skies. I just realized it's just rust hiding in the skies. But hey, that's better because you don't need to use the ampersand everywhere. And it's type enforced, I think. I think it must be because oh wait, no. Yeah, probably. If I see the prototype for high-low print function definition function and method. So let's see that methods. Oh, that's not. Is there like a documents language for building okay, syntax. Oh, that's just syntax specification. Scalars. Okay. So where's the community? Oh no, documentation. Contributing line references, compiler infrastructure language. Okay, let's see this. There's multi-line strings. That's cool. Oh, that's cool. So this is not in. So when that's cool. Understandable. I like that. So there's that. Wow. So it's just it has Java stuff in it. Name lookup, unqualified lookup, qualified name lookup. Where's the what? Okay, that's cool. Oh, okay. What? Oh, okay. Here we go. Holy. I understand this. I know what that is. But why is it capital I? What? Why is it capital I? Why? It makes me think Java has that, right? Java has that. Why? Is that the modifier? So, let's see. Is there like no... I apologize for that. Where is the... Oh, it's not defined anywhere. What the hell? So anyways, yeah. So let me just a second. I'm back. Yeah, let's start programming in gas now because yeah. There we go. So is it okay? Okay, good. So we're gonna compile using GCC, but make no mistake because we are not gonna use the standard library. So we're gonna compile it ourselves. So we're gonna go here, define our makefile. So we're gonna be using raw syscalls for this. So we're gonna go all GCC dash o main CFI. We can just go cffi.s, and what we're gonna do is no libc. So no libc, if I'm correct, GCC no libc. Yeah, no libc. Yep. So no libc, stdlib as well. We are compiling from scratch. Libc. Okay, so yeah, so now we have nothing, and we have to do that. So we're gonna learn gas again. So gas, GCC, GNU assembler. So we have that. Oh, it had. Oh, okay. So that's cool. Why is it? So the multi-line comment is like that, but the comments are. Why? Why? So anyways, start. We're in that text. Start. So we have that. Oh, okay. So this is cool. So that. Let's say we have our message. As you can see, we have that message. Then it's just ASCII's. It's ASCII. And we're gonna null terminate it because we're gonna be using, right? What's this? So, kernel system call procedure. What syscall? Oh, right, syscall is I see. Anyways, I must have made a mistake. So they define the length as okay. So len. So basically, that says that the current address that we are right now, subtract the length of the message. So that's how we get the message. And then we have this. So this is the exit syscall. We're gonna need this. Please don't tell me it's using. Okay, it's not using tabs. That's cool. Okay, that's cool. So, yep, you know that. So, with that, oh no, new line. Oh, okay. Oh, okay. It's not working. Why? Oh, that there's a dot data there. Dot data in UND sections. Global start text. Hello. Why is it data? We have text. We have global. We have start. Message. Oh, this is wrong because there you go. So if we change this to my favorite number, this is, yeah, that's hex. So we're gonna put it in hex, so it's not as, it's my favorite number. So we're gonna run CFI. There's no segfault. That's cool. Let's see. Does programming multiple projects in the same time good or not? Because I see doing multiple projects in each video. It depends on what you can do. You can't just always do that, especially if it's not suited for your skills. So if you're a beginner, I'd recommend focusing on one project for now. So when you get better, then you can start trying multiple projects at once. And start with 2 projects at the same time, and then build on from that. When you get better, well, just you'll see. You'll feel it when you finally can what is the word for it? Do it, achieve it. There you go. So now I am happy that there's like viewers who are returning. That's cool. So let's see. So when I paste this in, we are able to print that text there. Oh, whoops. I didn't make it. There we go. Oh, this is message. There we go. Should not work. Set dynamic for session sizes. What? Len dx. We have a message here. It is Linux. Oh, that's why. 32-bit. Well, I just use EDX. Oh no, that's already. Wait, what? Okay. Linux x86 right syscall. So we need, so this is for, oh yeah, there it is. So EAX, EBX, ECX, and EDX. So let me just clear this up. That data cannot be used when making a pi object. Recompile with -fpi. Why does it need fpi? Oh, because of this. Alright then. It did not work. So huh. That's weird. Yeah, yep, you're right. I'm not clinically diagnosed that I have ADHD, but it's pretty clear. Not diagnosed, but I'm pretty sure. So we can't use that. Weird. So if we use this call, so we use interrupt, the interrupt. Yeah, and it's the interrupt. But we, what if I want to use the syscall? So that's how we do that. So it's ECX, EDX, ECX. There it is. How do I? No. Oh, maybe that's why. Let's. Oh, whoops. Wow. Let's try that. Okay. It's not working. What is the problem? It only started when I did this. Picture. Ah! Why is it not working? Why is it not working? If I do this, it's not working. Yay. What if I just provide this manually? Let's just say it's 15. No. Okay. Still not the same. What is it anyway? The location are against data cannot be used when making a pi object. F pi. What if I just use static? It just died. Why are you not working? Maybe because we do this. Oh no. Even that, if I oh whoops, if I remove that, no, it does not help. What is your problem? What is the problem? Let me just. Was is the problem? Ah, yeah. No, look, this is basically the same. Let's see. If I modify the code to below, is it correct to have some side effects on 64-bit? What is this? What is this trickery? Oh, okay. So, what's LA? Leia? Leia GCC. gas. I think I've seen that before because I created my own stack-based compiler back then. And oh look, that's cool. Okay, so we have these and they're not links. Cool. Huh. Internet. Oh my god. Of course, there's nothing there. Meaning of layer in assembly. Load effective address. Okay, there it is. So we're just gonna load it. ECX, I guess. So what we need to do apparently is do this. Oh yeah, I've seen it earlier. This is what happens. And instead of that, we just do that. That's what I. There it is. It doesn't print anything though. But it compiled. Compiled. But it's not printing anything. This works, this doesn't. What if we just move out? Oh, this is move out. Whoops. Whoops. No. Make. No. No, it doesn't work. I'm almost there. I am almost there. So let's see. Whoops. What is this? What is this? Oh. Oh. No. Oh. Okay. Okay. Why are we doing that? Why are we doing that? The compiler is configured for Pi by default. Use GCC NumPy. Also, you seem to be recreating a 64-bit output, but your code is 32-bit. You may run. Okay. So, oh, okay. Okay. Whoa! We're programming in assembly now. We got that. We have print. So now we're just gonna have this. We're gonna have a subroutine. So we're gonna call it the write subroutine, and we're basically gonna expect a message in EAX basically. So wait a second, please. Oh wait, no, we can just pop it from the from the stack. Oh my goodness, so that we can call it from C. So GNU assembly is push 5 the same as move RSP 5? Depends. Yep. CABI though. Yeah. So push RSP. Oh yeah. Oh right. I forgot the CABI is different on Windows. And then even see it's really easy to write the correct code for that happens by luck to work in a particular attempt. For instance, you may leave. Oh my goodness, what is happening with my? Let me just fix it. Okay. So now code along right, but it happens to not actually do so in cases you have tested may fail randomly in a feature with different inputs, different execution environment, or when you make apparent unrelated changes in assembly, it works, therefore it's right, is not a valid argument. Yeah, that's true. Push RSP, and pop RSP are almost never correct. There might be some specialist uses, but not for beginners. You are probably thinking of push RPP and pop RPP. Which are required only if you're using RPP within the function. When returning from main, set EAX to the exit status, not EDI. If you call the exit function, then pass the status. If you call the exit function, then pass the status as a parameter to the exit function in ECX. If the caller doesn't use the exit status, then you won't notice a difference if you don't set it. Push 5 is the same as lay RSP. Move keyword. Okay. Oh, okay. So this is. Oh, so we load the address into RSP, and then we set that RSP to 5. So it's a quad word because it's 4 bytes. Oh, it's 8 bytes. Oh yeah, 8 bytes. That's yeah. It's 4 bytes. Wait, no. 2-bit integers. 2-byte integers, and there's 4 of them. That's why that's 8 bytes. Okay. Yeah. Thanks. Move keyword RSP5. So that is just the same as push 5. However, what if I wanted to push how to push address in what the hell was that search recommendation? We need to just see that how to push. Okay, so we have no choice. We have to do this. So this is what we need to do for that. So code for write So we're just gonna copy paste that into there. So now we can also remove the comments. Go. So that, and then we return. Oh wait, is it? Gas return. Is it just red? Okay, it's just red. Okay, it doesn't. Okay, so I'm skeptical about that. So now, yeah, we need to. Okay. EX. Oh, okay. So it's ECX then. I saw that. I think on the we need to do that in ECX. Oh no, it's 0. Okay, so EAX is 0. Okay, so now we can call this. Let's see. Oh, it's yeah. We're close. So probably yeah, this. Let's see. Okay, segment. Yeah, what if you just. Wait, what was that instruction? Oh, no wonder. Ah. Oh yeah. It's annoying. Forgot that it's different. Yeah, see, no segfault anymore. So, what do you think about my PFP? There's like hidden messages everywhere in it. So message. We're gonna put it in ECX. So we're just gonna go pop into ECX and then pop into, actually get len. So we're gonna find that. So that's correct, right? I hope it is. That's just a label, so that should compile. No. So we do need. Oh, this, right? So still have that. This is the, yeah. That's like an address, so now technically we don't need that, but why? Okay, there it is. So we just need to specify the len automatically, which is what you will do with get len. So in get len, Sterling. What we're gonna do is, wait, can we just push? Why can't I just push message in here? Oh, whoops, message. And then here we go pop into ECX, I always. Okay, so it does segment fault, probably because we don't have, so fine. We're gonna follow this, yeah. So we load the immediate register of message into some random, let's say EAX. So so this is C. So we're gonna, how is it? RSP is a stock. Oh yeah, it's the stock pointer, so we don't really need to do anything. So we go, okay, so RSP minus the size of message. So I reckon it's 8 bytes. 8 bytes, 8 bits. Yeah, this is bits. And then we move. No, wait, no, we can't. Wait, no, that's it. That's true. Oh, that's it. No, that's all you need to do. And then let's see if it. Yeah, is it? Ooh, okay. So let's see. ARSP SP8. Oh, okay. This is gas, right? No wonder why I'm getting. Anyways, let's change this. So, Intel. Okay, so we have push RBP, save old base pointer. So RBP base pointer, move, set the new base pointer. I mean, no, let's move. RSP, RBP, and then allocate. So we need 8. So 8 bits for this. So 16 RSP P restore. Okay, restore pointer return. So this is the epilogue, the function. Oh, this is the function. So I need to copy paste this. Put in Sterling. Yeah, and then just remove the comments. Oh, whoops. Wrong button. There we go. So that should work. So the function body goes there. We have that. function body. So how do we push? So push Q, pop Q. Okay, so we need push out because we're in 32-bit mode. So push out. We just do that. So 16. So this is stack. So here's the new stack. So so this is RBP epilogue pop. So to push data. So okay, so we're gonna push L message. Will that work? This shouldn't be any problems. Okay, by registering RBP. ESP. So we're gonna use the ESP. EBP. What the hell? RBP. Where's the RBP? So EBP. EBP and EBP as well here. And RSP is ESP. Why is it that way though? So, oh my goodness, it's this. Okay, compiled, good. So it works. We push message. So we actually need this as well here. There. 9. Voice to my message. It is in ECX. That's where, yeah. What if we LEA, ECX? Basically the reference. Yeah, okay. Nope. Now, how can I dereference? Oh. Okay, push message into here. That should give us the address. So how do we do we just, no, it doesn't work. So how assembly reference label assembling name for, yeah, yep, uh-huh. Okay, so anyways, that doesn't work. Weird. Now why doesn't it work? What is the problem? So if we just there it is, it works. So I have to do that. Oh, whoops. It does not work. It doesn't work. What is the problem? What is the problem? GDB CFFI. Run, just run it. Oh. Okay. So let's run it again. Break at start. Run. Okay. We're in there. So let's print in ECX. It should be garbage. Oh. Ah. Wait, how do I GTP how to print register? Info registers. Oh, there it is. So ECX is currently 0. Okay. We step. I didn't step in into the okay, so let's run it again. Next. Step in. I did not. Well, I have no choice. So, it didn't. Okay, so it didn't do that. Let's. Why not? Just G. Oh no, small G. Make break right. Okay, there we go. We have our stuff. So next step. Oh, I haven't run it yet. So run. Okay, we're there. Next. Okay, pop LECX. So IR nurse. Oh my goodness. Why is it 0? Let me just refresh this. I see. Work. So next. And then return it to the start function. And then we start doing stuff. And then that's it. Boom. Why aren't you working? Gas assembly. How to push and pop an address. So Intel, AT&T. So load immediate address. Then how do I pop it? How do I pop it? No, we already pop it into ECX. We already have the address. It should have printed it. Is it a quad? Why won't you work for the love of God? Move register offset to foo. Not in Leia. In 32-bit mode, Leia is 1 byte longer and can run on fewer execution ports on most CPUs. So totally, it's pointless for putting a 32-bit constraint into a constant into a register, including absolute address of a symbol. RIP relative. Leia is useful in 64-bit mode, but that machine code feature only exists in 64-bit mode. It has special syntax in the RESM source. How to load address of a function. You know what? What I'm gonna test that. See, yeah, I'm gonna need to I can try right normally stdio.h. Yeah, I had enough. So anyways, gcc-s-o0 let's see. So let's see. So yeah, there's a string. This is the write function, and this is the main function. So in the main function we call write, but before that we load the string into a RAX. We move Q RAX RDI. Whoa. Okay, so this is the function prologue. This is the epilogue. This, however, just a second. So we go here. Yeah, we call puts. We sub. Okay, so we. No, they manually. Okay. So this is offset stuff. We don't even need to pop. Okay. RDI. Then in here, I don't see them touching Oh, there's the RDI. Wait, no. What? So this is when okay. This just hold on a second. RDI is holding nothing as of right now. So you're telling me it used registers? Wait, what? RAX. Okay, so we put the string into RAX, and then we move RAX to RDI for some reason, and then we call write. Then in here, we allocate for the message variable. We put let's move this. Okay, so oh, wait a second. That may also, yeah, let me sabotage M32. Yeah, okay, change. So let's, what the clear start. Just don't, just ignore that. So, okay, there we go. So we push that 55 add, and then in what the hell is this? Why is there? It's static. It's static. Why are you? Why are you using the global offset table? I hate this. I hate this. What the hell? What the? It's static. No libc. Standard. Oh, there you go. Still the same. And this is standard. No pi. Oh, no, we do have that. What if we increase it just one? Just one. Okay, okay, we're good. We're good. It just it just inlined it. It just in why are you just yeah. Very great. It doesn't even call it here now. Yeah, I hate this. So we can't really do anything. So, oh my goodness, how do I get rid of the global offset table bull crap? So let's see. We call add 3495. So the stack pointer. So we de-add. It's okay, okay. Because we have what? Okay, no, huh? It's, who cares? What is a leaf? Why? Why? We push L EPP. Okay, so this is the prologue. We call whatever the hell that is. We add that. Oh my god. We're just adding two numbers. Why is there a... Oh my goodness. Oh, I think at least we'll be able to. How do I ASM in C? Yeah, I'm gonna end the stream in a bit. So let's see. N what? This is extended inline assembly. So 0 is our n, and we write it back into our n. What does huh? How to use C inline assembly? Input operands, output operands. Add in one, in two. MSPC. Oh, that's actually pretty cool. So out variable C variables that will receive the results, typically prefixed with equal sign or plus constraints. Input operands into R var in R var memory or CC. Extended assembly class values within CPU. Come back to this in my free time, and yeah, yep. Ciao guys, ciao. My brain is just fried from the assembly.